Number 12, write that number as a decimal. So if there are 4 whole numbers as a fraction, we're not changing this value, we're just writing it as a decimal, so that we know it's going to be 4 point something. Now we need to change 3/8 to a decimal. So 3 divided by 8. 8 does not go into 3, so you add a decimal and a 0. 8 goes into 33 times. It's 24. Subtract, you get 6. Add a 0 and bring it down. 8 goes into 67 times. 8 times 7 is 56. Minus and get 4. Add a 0 and bring it down. 8 goes into 40 5 times. 8 times 5 is 40, and those will cancel. So our answer for 12 is 4.375. 13, express that as a decimal. The same kind of thing. 5 divided by 12. 5 divided by 12. A decimal. 12 goes into 54 times. 12 times 4 is 48. When you subtract, you get 2. Add a 0 and bring it down. 12 goes into 20 once. 12 minus, get 8, bring down the 0. 12 goes into 86 times. 12 times 6 is 72. Minus and you get 8. When you add a 0 and bring it down, you get 80. And so we're just going to keep doing 80, which means that's repeating. So you'd get 0.416 repeating. 14. Compare 1/4 and 25 over 99. Okay, compare the decimal forms. Well, 1/4 we know is 0.25. If you did 25 divided by 99, you would get 0.25 repeating. So how are they alike and how are they different? Well, they're alike because they're both 0.25. They're different because 1/4 is terminating and 25 over 99 is repeating. Find the 2 square roots of 1 over 16. So we're simply finding the square root of the top and the square root of the bottom. So the square root of 1 is 1, and the square root of 16 is 4. It says find the 2 square roots. Every number has 2 square roots. 1/4 times 1/4 gives you 1/16. What else times itself gives you 1/16? Negative 1/4. So those are the 2 square roots of 1/16. Estimate the square root of 40 to 2 decimal places. Okay. So square root of 40. 2 closest perfect squares are 36 and 49. So to estimate these, make it a fraction, and on top we take the square root of our number minus the lower square root. So 40 minus 36. For our denominator, we take our upper square and we subtract the lower square. So 49 minus 36, and we would get, this is 4 over 13. And I believe we did that worry, yeah. We did that for this problem on the front, number 7. And when we did the square root of 40, we got, it says the 2 decimal places, but since we already did that, we can just go ahead and put 6.3. I know it says the 2 decimal places, but we can just use 6.3. How are these different and alike? Well, if we write these, if we were to write them out, so that first one would be -5 times -5 is -5 times -5 times -5. There are 5 negatives. That's an odd number of negatives, so we're going to get a negative answer. Multiply all that, we get 3,125. If we do the positive equivalence, 5 times 5, 5 times 5 times 5, we'd get a positive 3,125. So how are they alike? Well, they have the same base number. I'm sorry. They have same exponent, but different bases. And we ended up getting the same absolute values, but one's on opposite sides of the number of 0. Opposite sides of a number line. So this is negative 3,125. This would be positive 3,125. So they're like because they're the same distance from 0, but one is negative and the other is positive. On to 18. Choose 3 of the following terms. Make the diagram true. So we have whole numbers, integers, rational numbers, irrational numbers, and real numbers. I'll tell you right now, irrational numbers will not work anywhere. But there are so many other combinations that work. So what's the smallest group that we have? Well, that would be whole numbers. So if A are whole numbers, every whole number is also in the set of integers. Every integer is also, every integer is in the set of rational numbers. So that's one answer. Or you could put, hey, we're going to go with, if A is integers, every integer is also rational, and every rational is in the set of real numbers. So there are multiple correct answers here. As long as you keep going out and not in, it works.